Good morning, everybody. Sorry for the delay. We're going to go ahead and get started with today's webinar. Hi, my name is Nathan Drew. I'm a senior software engineer here at the Disty Corporation, and I am the technical lead of the GL Studio project. In today's webinar, I'll be giving an overview of the major features for GL Studio 8, our upcoming release, as well as giving a live demonstration of some of these new major features. So just to give a quick overview of who we are here at Disty, we've been around since 1994, and we do HMI and UI solutions with our GL Studio product. Here is a selected list of our customers. You can see that in terms of industries for HMI and UI, we stretch the gamut from everywhere from the Department of Defense to space endeavors, aerospace, automotive, including even medical, trains, and among other things. So with our successes in production, we are currently flying in a number of aircraft as well as operating in automotive. Jaguar Land Rover has standardized on us. We're also used in agriculture. We're used in the Fendt tractors. And like I said, we're also used in medical and power generation with our safety critical expertise and products. And this is just a select list of our partners here in our ecosystem. We support with our software everything from every OS and RTOS under the sun running on any kind of hardware, as well as all the various standards that we support with our runtimes, the OpenGL ES, SC, and so forth. Not an exhaustive list, and we collaborate with all kinds of partners on any variety of platform, both hardware and software. So today I'm going to be going over GL Studio 8, as I said, our upcoming release for our tool, and the major features that are contained therein. So these 4 features are GL Studio on macOS. So traditionally, our tool has been fully supported on Windows and Linux, but now with the release of GL Studio 8, we'll be adding macOS to that ecosystem. So you'll be able to use our same UI tool, HMI development tool, on any desktop development platform. We've also made great strides in editor internationalization. There were a number of places where non-Latin languages were not fully supported in our editor, but with GL Studio 8, we will be correcting those areas. Most notably being able to write code and comments and things like that inside the editor. We're also introducing an editor interactive tutorial feature. So this will allow you to complete a tutorial on how to use GL Studio entirely within the editor. No need to alt tab between a video or a document, and this will allow faster onboarding, making it easy to get up to speed on how to use GL Studio. And last but not least, we're introducing an automatic texture atlasing feature. This will essentially allows a better workflow because artists can use many smaller images that will automatically be combined into a larger image, resulting in better runtime performance. So first up, GL Studio on macOS. So with GL Studio 8, the core suite of GL Studio tools will become available on macOS. So this includes our editor, our 3 code generators, and our package system. So with the editor, that's more or less self-explanatory. With the desktop code generator, you'll be able to create universal apps that run on any supported Mac, whether they be an Intel Mac or the new Apple Silicon M1 Macs. With our ES or embedded systems code generator, at release, you'll be able to deploy to WebGL. So this is a way of deploying web applications from macOS. In a future release, we plan to release support for iDevices, including iOS, Apple Watches, TV, and so forth. This will also allow users to prototype embedded content. For example, if you were to deploy to embedded Linux or Android or any other embedded system, you can prototype this content on macOS. And then the safety critical code generator, where you'll be able to prototype DO178C DAL-A or ISO 26262 for automotive applications on desktop macOS. So as a designer or an artist on macOS, you can prototype those applications before handing off a design to an engineer to implement on the target. And then packages, our deployment systems, our behaviors, all the great content that you would expect for GL Studio will also be available on macOS. So to use GL Studio on macOS, you will simply need a Mac that is currently supported by Apple. So that is to say a 64-bit Intel or Apple Silicon M1 Mac running macOS 10.14 or newer. A dedicated GPU is recommended. So in terms of hardware, because we are a fully 3D tool and it works best with hardware accelerated graphics. Although any hardware that is currently supported by Apple should be able to run the editor. But we do recommend a discrete GPU for optimal performance. To use the tool, you will need Xcode installed from the App Store. So GL Studio is a code generator. You will need Xcode in order to actually build an application on macOS. So this is just a free download from the App Store. So you'll want to make sure that's installed before you try to use GL Studio. And if you are using Apple Silicon or an M1 Mac, you will need Rosetta 2 in order to run the editor. At the moment, our runtime is a universal binary. However, currently the editor is a Intel binary. So this translation layer will be required for GL Studio 8. However, in a future release, we will be removing this requirement as third-party software that we rely on updates to support both Intel and ARM Macs. So I'm going to go into a demonstration on using macOS, on using GL Studio on macOS. Some of this will be familiar to veteran GL Studio users. However, it is yet to be seen on macOS. So the first thing I'm going to do is show the install process, and then I'm going to show some basic workflows for designers and engineers running on macOS. So I'm going to cancel out of my PowerPoint presentation here. We'll get this to zoom in on my screen here on my Mac. So I'm actually presenting this presentation on a Windows PC, and I have a capture card that is routing the output from my Mac over to my Macintosh PC over here to my Windows PC. So for the installation process, when you download GL Studio from us, you will get it in this nice DMG or disk image file. And installing GL Studio on macOS is really easy. All you have to do is double click on the installer, like so. And then drag and drop the resulting application over into your apps folder. So this will copy the content over into your applications folder from the installer. So this is copying the editor, the code generators, their packages, all the other content that is associated with the GL Studio tool. So once that's finished, all you have to do is double click and start the editor. It's that simple. And there you have it. 30 seconds flat. So that's how easy it is to install GL Studio on macOS. So now that we have GL Studio up and running, I'm going to show a brief designer workflow. So in the designer workflow, as an artist or designer, the idea is you drag and drop assets, whether they be Photoshop or SVG or from other tools, into GL Studio and have them import into GL Studio as native GL Studio objects. From there, making adjustments to these assets using native tools, the ones that you're most familiar with. And as you make those changes, seeing those changes automatically re-import into GL Studio. And then once doing those iterations and you are satisfied with what it looks like, running the application by using our deployment system, clicking the run button, so to speak. So I'm going to show what that looks like on macOS. Cancel back out of our PowerPoint and move back over to the Mac. The first thing I'm going to do is create a new project. So over here on the top left, we have the Create Project button, and I'm going to use the default project, and I'm going to use the default project name. Hit Create. This will extract the default project. And here we have some default content. So I'm going to go ahead and delete this content because I'm going to import a Photoshop file. To do that, I'm going to click on the Art button, which will open up the art assets associated with this project. And in this starter project, we have this Photoshop file that displays a automotive HUD. So I'm going to drag and drop this onto GL Studio. And by doing so, GL Studio will parse the Photoshop file. It will take each of the individual layers and it will convert those individual layers into GL Studio objects. So over here in the Geometry tab, you can see that we have this disty HUD. That is the Photoshop file's content. And here you can see various objects, the various layers that got imported, like as I toggle their visibility in the editor. So as part of this import system, it's called our catalyzer system. Essentially, this import is governed by a Python script that knows how to import Photoshop files. And the beauty of this system is it also maintains a connection back to the original file. So if you right-click this little icon, this little magnifying glass icon, it will open up this art asset in the original tool, in this case, Photoshop. So this is the Photoshop file that got imported into GL Studio. So as changes are made to the Photoshop file and saved, for example, let's say I move this disty logo up somewhat, like so. As changes are made and the file is saved, GL Studio automatically detects that changes are made and will automatically re-import the content back into GL Studio with those changes. So you see that I adjusted the location of the icon in Photoshop, I saved, and then that change was immediately picked up by GL Studio. So you can make changes not only in Photoshop, but also in GL Studio, and all of those changes are tracked and the content is automatically re-imported. So now I'm going to go ahead and adjust my application size to match the size of my art asset, and I'm going to adjust the location of this HUD to be centered within my design, like so. And now that I'm more or less happy with what I have so far, I'm going to hit the Run button. So this Run button actually does a lot under the hood. So what it does is it generates the code associated with this application, which describes all of the different objects that are in my design. It calls CMake to generate an Xcode project. And then using Xcode, it will compile the generated code alongside all the other user code to build the application. The beauty of it is in this workflow, the artist or designer doesn't need to know any of that at all. They simply need to click the Run button. The design is essentially it's transparent to the user that that's the case. And then as further, you can make further adjustments. For example, I'm going to adjust the eye point to match the new size of my application and hit Run, and it's very quick to iterate from there and simply clicking the Run button and seeing the resulting changes. So now we have the application looking exactly the way we want it to. So that's the quick designer workflow. So in conjunction with the designer workflow, either before, after, or during, the engineer can also work on the project, can work on the same project at the same time, actually. And For the engineer workflow, the engineer will write, attach, and configure object behaviors and business logic for the application. So this is code written in one of our C++ APIs. Other tasks include integrating third-party libraries, whether they be written in C, C++, or native macOS Objective-C or C++ source. Configuring the CMake for the project, which can be used to add third-party libraries and frameworks. And then using Xcode to write code, develop, and debug the resulting application. So I'm going to show the engineer workflow. So back to GL Studio, I'm going to select, let's say, the compass group, and I'm going to attach a behavior to this group. So in GL Studio parlance, a behavior is a modular header file, templated header file written against our C++ API that can be attached to an arbitrary object. So over here in the object properties, I click Browse on Behaviors, and I'm going to select the spin behavior from this list. So this will cause the object to spin about an axis, in this case, the z-axis. So you'll notice that when I selected this behavior that there were two changes. There was a change in the geometry tab. You'll notice that the class name for this object is now templated. It now derives from group, but it is of type spin. And these two new properties have appeared in the object properties tab. So these are properties that can be configured by the engineer in the header file. And now these object properties can be changed without having to write any code. So that makes configuring these objects very convenient. So now I'm going to hit the Run button and have GL Studio regenerate and compile my code again through Xcode. And we should see that the object is now indeed spinning. So using behaviors, whether written by disti, provided through our package system, or written yourself, can make it very quick to add behavior to your design. So the next thing I'm going to do is I'm going to show how to develop code itself. So up here at the top, there's this debug button. I'm going to click it, and the debug button is going to open up the generated Xcode project associated with this GL Studio project. So this will allow me to write code, set breakpoints, debug, and various tasks like that. Over here on the left, we have the list of source files that are associated with this project, including generated source as well as user written source. In this case, we're looking for the package header file, aka behavior, called spin, which is right here. So this is the spin behavior header file, and it contains several important parts. Something to note about these behaviors and all of our packages for that matter is they have their source code fully available to you and are permissively licensed. So all of these behaviors and deployments and whatnot, all the source code is available to you to study and to customize and to use in your projects. Here at the top of the file, we have a little XML block that describes exactly what properties should appear in the editor. So for the case of this particular behavior, it is spin speed and spin axis. So for each of these property blocks, a line item will appear in the object properties in the editor for the user to customize without having to write any additional code. And then down here, we have the behavior itself written against our C++ API. Note that it is a templated class, so it can be applied to any kind of object. And then down here in the calculate function is the actual functionality of this behavior and what it is doing. Calculate is called every frame with the current time, and it is simply taking the delta time and applying a rotation based on speed and delta time. So from here in Xcode, things I can do, I can set a breakpoint and I can run my application from Xcode, just as you would expect from any other IDE. And I'll be able to step through and debug my code as needed. So I've run my application. You see that it is running. We hit the breakpoint. And in this fashion, you'll be able to debug any of your user code, behaviors, business logic within the GL Studio application. So you can choose to run the GeoStudio application either from Xcode or from GeoStudio in the engineer workflow. Okay, so we are now looking at our code, so let's make some changes. So I'm going to add a little bit of extra behavior to make the object pulse in addition to spinning. So I'm just going to add some simple logic that adjusts the scale as well as the rotation. So to do so, I'm just going to use a sine curve that takes in the position, since we've already calculated a position based on delta time. And I'm just going to divide that by 10 and divide the result by 10. So this will give us a very small sine wave with a small amplitude that we can add to our scale. And then I'm going to pass into our dynamic scale function, controls the scale of an object, and I'm going to do 1 plus scale, which should get me a range that centers on 1 and goes up and down. And I'm going to do that on the X and Y axes. I'm going to leave the Z axis at 1. So like this, you make adjustments to code and then see the result. As I mentioned before, you can either run the application from Xcode or from GeoStudio. So just to be different this time, I'm going to run this from GeoStudio. And then we should see the resulting code change. We should see the resulting object pulse slightly, and as you can see, it is now pulsing slightly. So now in this fashion, I can now reuse this behavior. I can apply it to other objects that will also spin and pulse. So that is the designer and engineer workflows in macOS. So with GeoStudio being released for macOS, it's the same great GeoStudio experience you've come to know and love that is available now on just one other platform. The design files are exactly the same between Windows, Linux, and macOS, our supported platforms, as well as the generated code. So you can have engineers and designers working on different desktop platforms for development and collaborate and share on the same project. Write your GeoStudio design once and build on any target, whether it be a desktop target or embedded target. So next up is editor internationalization. So to give a quick background into into what I mean in regards to GeoStudio 8's internationalization, just a quick review of some historical items concerning our editor and runtime internationalization. So in terms of interface language, the GeoStudio editor has supported other languages since 2014, since GeoStudio 5. These languages include English, simplified Chinese, Korean, and Japanese. So these are the interface languages for the editor, things such as all the dialogues and the object properties and things of that nature. In terms of runtime support for Unicode characters, we have supported full Unicode with ligatures and right to left since 2015. We've actually supported Unicode since before that, but full ligatures and right to left support was added in 2015, completing full Unicode runtime support. So what I'm mentioning here is the GLSCTL text box object. This allows you to render text in any language, including ligatures, languages like Arabic, Hindi, and Thai. So specifically what I'm talking about in GeoStudio 8 are all of the remaining areas for supporting where users can enter text. So these are things like the code browser, the code editor, the GLS file names and file paths, which previously were only Latin only, and things like file names, fonts, sounds, and other resources that are loaded at runtime. All of these features coming in GeoStudio 8 will now fully support Unicode and can have arbitrary characters in their names. There are also a few places in the runtime where we have added additional support in addition to all of the support that already existed. Things like the application title for desktop applications and the aforementioned resources loaded at runtime, including textures, fonts, sounds, and so forth. So for today's demonstration, I'm going to show off these new areas and some of the previous areas where internationalization has been added. So for this demonstration, I'm going to change the editor to one of our other supported languages. For the purposes of this webinar, I will be using Japanese and leveraging my limited Japanese knowledge for the purposes of this webinar. But just keep in mind that this can be done in any other language, including languages that the editor does not have a display language for. So this could be done in any language. So I'm going to do that. The first thing I'm going to do, I'm going to change my editor language and create a project in another language. We will back out of PowerPoint again. And I'm going to first, like I said, change my editor language to another language. So first I will go into Preferences, and I'm going to change my editor language from English to Japanese. Hit OK. It's going to prompt me to restart. I'm going to say yes. And let's go ahead and quit out of all this other stuff. And reopen GL Studio. So now my interface language is Japanese. You can see that is now the case. And let's arrange my windows really quickly here. And prepare to create a new project in another language. So like before, click the new project button, except this time I'm going to name the project in Japanese, my project. Like so. So now this file path will be a Japanese file path to my project. Hit the create button. And like before, we have some sample content, which we will be doing some interesting things with momentarily. So what I'm going to do with this is I'm going to arrange some GL Studio objects, a knob, a text grid, and a CTL text box. And I'm going to write some code in Japanese to make a property connection between the knob's rotational value and the text value shown in the text grid, the numeric value. And I'm also going to show some runtime Unicode text, which is a feature that has been supported for a while, but it bears repeating. So that's what I'm going to put together in GL Studio. Some code written in another language, as well as some runtime content also created in another language. Wait for this to zoom back in. There we go. All right. So over here in my geometry, I'm going to extract the knob object. I'm going to use this for my input and then delete the remaining default content. I'm going to drag this knob over to the center. And new to GL Studio 8, I'm going to rename this object with a Japanese name. My rare circle. I'm going to create a text grid object that I will be assigning this rotational value to. We'll put some default text in here, and I'm going to need to configure this text grid appropriately. So I'm going to need to do things like adjusting the number of row and columns to 1 and 3 respectively. I'm going to need to increase the text size so that it is visible, like so. Adjust its location a little bit. And I need to knock the character spacing down a bit. It's probably a little too little, so let's do 0.7. And I need to remove the outline. And then I'm going to rename this object number, like so. And to show some runtime text functionality, I'm going to create a CTL text box object, and I'm going to have some Japanese text in here as well. In this case, it's going to be GL Studio in Japanese. And like before, I'm going to adjust the size of my text to make it visible, as well as remove the outline. All right, so now we have some objects. It's time to write some code in another language. So I'm going to switch to the code browser and code editor. And here I'm going to add a new property to my design. And this property will contain the value that will be displayed in the text grid. So for this object, this property, excuse me, I'm going to want a float, and I'm going to call my float value. And here in the comment, I'm going to add a comment. Being able to write code and documentation in any language. And then here in the setter method for this property, I'm going to write some logic that will assign the incoming value to the text value of my text object. So the first thing I'm going to do, assign the incoming value to my member variable, value. And then assign that value to the text object's text. Like so. I need to grab the value that is the incoming value, cast to int, like so. So that will take the incoming value and set its integer value to the text of the text grid. I also need to take the value from the knob and pass it into this function. So I'm going to do that in calculate. So switch over to calculate. So into value, I'm going to pass the value from my knob, my rare circle. And I'm going to take its position val to pass into my value property, like so. So now when I build and run my application with these code and with these objects generated and compiled in Japanese, the result should be a knob that I can rotate that will increment and decrement the value of this text grid accordingly. So essentially, whether you decide to write code in English or another language, or documentation in English or another language, GL Studio 8 now fully supports this functionality. So we have our running application, we have our starting value, and as I rotate the knob, you can see that the value of the text grid goes up and goes down accordingly. So GL Studio gives the freedom for code to be written and projects to be constructed entirely in one's native language. This is the big draw for editor internationalization in GL Studio 8. English is no longer the only viable development option when working in the editor. Moving on. So next up, we have editor interactive tutorials. So editor interactive tutorials are tutorials that are integrated entirely in the editor. And the big draw of this, mainly, no need to alt-tab between a tutorial document and a video. This makes things very easy to keep your place in the tutorial because the tutorial does not move on until you have completed all of the steps necessary to move on. So these tutorials will automatically highlight the objects you need to click on for the tasks that you need to complete to continue in the tutorial. So this makes onboarding and learning how to use GL Studio easier now than ever. When we release GL Studio 8, there will be an automotive HUD tutorial available. However, we are hard at work developing more official tutorials, which will be on their way in future versions. This tutorial content is modular and customizable. It is written in Python against our Python API. And this source code for these tutorials is fully available to you. So these tutorials can be customized to suit your organization and your organization's workflow. So if your organization is developing a GL Studio project with a special workflow, you can onboard your own employees with this workflow using this same system. The way that these tutorials work is that in Python, there are conditions that must be fulfilled within the GL Studio design before the user of the tutorial is allowed to move on to the next step. So this, in conjunction with highlighting important parts of the editor, makes it very difficult to get lost in the instructions, makes it very easy to keep your place and learn each of the tasks that are required of you as you're learning to use GL Studio. So I'm going to now show what this looks like. So we're going to create another project, start a tutorial, and give an overview on how the editor will guide you through creating a design in GL Studio and learning the tool. So let's do that. First, I'm going to switch my editor language back to English and restart. And create a new project, just like we've done before. I'm going to call this project tutorial. And delete the default content. So to use the tutorials, the tutorial buttons are in the top toolbar. So we have these three buttons at the top to select, start, and continue a existing tutorial. So in the select tutorial button, for now, there is only one tutorial. As I mentioned, the automotive HUD tutorial, but in the future, as more tutorials are written, or if you have your own custom tutorial specific to your organization, they will appear in this list to be selected. So to start a tutorial, you simply click the Start Tutorial button, and it will pop up a new tab that will show the tutorial steps and instructions. So as you complete each step of the tutorial, this next button will be available for you to continue. So just to show how that works, I'm just going to click through the tutorial until we hit our first step that requires us to do something other than read and learn. So I've clicked through to the first actionable step, and you can see now that the Art button is pulsing with a highlighter. This is directing me to click on that button per the steps in the tutorial. If we scroll down the tutorial, we'll notice that this next button is currently grayed out. I will not be able to click this button until I follow the steps of the tutorial. So let's do that. The tutorial is expecting me to click the Art button and then drag and drop the disty Photoshop file, as I showed in the designer workflow, into the editor. So let's do that. We click on the Art button, drag and drop the correct Photoshop file onto the editor. And like before, it will parse that Photoshop file and import its layers as GL Studio objects. And once it is finished, you'll now notice that the highlighter has now gone away. And now the next button is no longer grayed out. I am now able to continue on to the next step. So in this fashion, you continue through the tutorial, and as you hit each step, the step will highlight important features of the editor to direct you to them, so that it becomes very easy to follow the instructions and learn how to use the tool. So let's just say that I've gone as far in the tutorial as I'm going to go today, and I want to leave and I'm going to leave it here and come back to it later. If you leave the editor at this point, you'll be able to continue the tutorial where you left off when you come back. So let's show how that works. So I've exited the editor. I'm going to restart the editor and then reload my project to continue my tutorial where I left off. So you may remember that when we left off, we were at tutorial step 1.2. And when I continue the tutorial, you can see that we are still on step 1.2, right where we left off, and we can continue following the steps. And as we do so, this next button, as well as those in all future steps, will be allowed to continue in the tutorial. So just like that, to learn how to use GL Studio, simply create a project, hit the Start Tutorial button, and begin learning. That's the power of our editor interactive tutorials. Automatic texture atlasing, next up. So automatic texture atlasing is an optimization technique that allows artists to work with individual files that are easy to work with, while automatically at generation time combining them into larger images containing all of the content called atlases. Combining smaller images into one larger image improves performance at runtime, especially on embedded targets. So over here to the right is an example of an atlas. You can see all the different parts of the HUD tutorial content that are all in one image rather than individual images. So when this feature is enabled, your design will be optimized, generated, and restored. Noting that this does slightly increase code generation time and undo history is lost when this occurs. So it is recommended to enable this feature when you're ready to release, so that you get the benefit of the optimization at release time while being able to still iterate quickly at debug time and development time. So to enable and disable texture atlasing, this shows up as its own setting in the deployment dialog, the deployment settings dialog. So this is where you go to enable or disable it if you're ready to do a release build or you're ready to test the functionality of texture atlasing. So I'm going to give an overview. I'm going to give a demonstration of exactly how that works, including showing you where this settings dialog is. So let's do that. Let's get out of this project like so. And once again, we are going to make a new project for our texture atlasing. So as before, same default project, but we're going to call it atlasing. Create our new project. And delete our default content. So I'm going to need some art assets to atlas. So I'm going to need to open my art folder for my atlasing project, and I'm going to navigate to where I have some album covers that I'm going to use for this example. So I'm just going to copy this content over into my project. And I'm going to drag and drop some of these onto the editor to create polygons for this demonstration that will be atlased. So I've just dragged and dropped 4 of these album covers onto GL Studio. This has created 4 separate polygon objects. So I'm going to go ahead and arrange these in my scene, these 4 individual images. To enable texture atlasing or to disable texture atlasing, you do so from the settings dialog. So that's this gear icon right here. And this will open up the deployment settings for this current deployment. This allows you to change anything anywhere from the Visual Studio version you're using on Windows, if you're building on Windows, to your target architecture, to all of your generation settings like the texture atlas. So to enable, simply click Enable Texture Atlasing and hit OK. At this point, when you run the application, when the code generator runs, it will run the texture atlasing step, which will combine all of your individual images into a single image for runtime. So while this is generating and building, I'm going to go ahead and navigate to where that generated atlas lives to show you what happened here. So here in my project, I'm going to go to Engineering, Generated Atlases, and open up the generated atlas for this project. So you can see that our 4 individual images at design time have changed into a single image that contains the content of all 4 at runtime. So this reduces the texture swap overhead, which improves performance, making texture atlasing very useful, especially in projects that have lots of icons, icons especially. Being able to combine potentially hundreds of icons into a single image, which would be very unwieldy to edit this from an art standpoint, but at runtime makes things very performant, and this entire process is fully automated. So like I just showed, you can take a look at exactly what's going on in your atlas in the generated textures folder. So in the event that you need to debug what's going on with the texture atlasing or decide which images need to be part of which atlas or exclude some images from atlasing, you can take a look at the generated atlas to make those determinations. Okay, wrapping up. So, GeoStudio 8. We plan to make our GeoStudio 8 release sometime in December of 2021. We will have a preview version available that will be demonstrated live at ITSEC 2021, as well as CES 2022. Our macOS beta build will also be available on a selective basis if you wish to try out GeoStudio 8 on macOS. And just to review the key features for our GeoStudio 8 release, GeoStudio now being supported on macOS, further improvements to editor internationalization, editor interactive tutorials, automatic texture atlasing, and bug fixes, package updates, and much, much more. GeoStudio 8, everybody. So now I will open the floor to questions. And I need to, let's see if we can do this. If I can enable over in the conversation, unmuting the chat. So I have unmuted the chat. So if there are any questions so there should be a chat button in Teams in the top right corner-ish, or the left side of the top right corner, where you can type in the chat and I can answer any and all questions that you may have. Any questions? All right. Well, that's okay. If you think of anything, you can always email your questions to sales@disty.com or support@disty.com. If you come up with any questions later, I'd like to thank everybody for attending today's webinar. I hope you found it informative, and I hope that you are as excited as I am for the upcoming release of GeoStudio 8.0. Thank you.